Yeah, YouTubers, Tazman here, bringing you a programming logic kind of tutorial, education type of thing. So I love teaching, and I've been told sometimes I can explain things very well and make them a little easier to understand. Now, programming is a really complex thing. Um, but if you understand some of the basics, it becomes a lot easier. And so instead of right now jumping into actual programming languages, we're going to learn the logic behind programming. Because if you understand the logic, you can learn any language because it all is the same logic. And it's just different syntax. The way you actually, the verbiage and stuff that you use to do what you want changes from language to language. Sorry, I need a drink. So one of the first things we need to kind of understand to even get into programming is just a really basic understanding of how a computer works. Because a computer, in all reality, is a very dumb piece of machine. It does not understand anything more than a 1 and a 0. That's it. That's all a computer can speak is 1 and 0. And it's really kind of hard to, walk up to a computer if you spoke computer and you just walk up and said 1. Well, it doesn't know what that means. Or 0. That doesn't hold a lot of information. So what we can do sometimes is we can string things together. So instead of having just a 1 or a 0, and the reason it's a 1 or 0 because 1 means on and 0, means off. Oh boy, I can't write. So that's all a computer understands. It's memory, it's hard drive. It's either has a value of 1 or it has the value, it's on, or it doesn't have a value and it's off. So the way we get a computer to finally understand things from us is we tell it, okay, computer, I'm going to give you a sequence of 1s and 0s. And if it's this sequence, it means this. So instead, this is called a bit. And that's all a computer understands, equals a 1 or a 0. But we can't talk like that. We can't just say 1, 0, and that's it. We need the computer to understand more. And so when they were developing computers, they created the memory, right? So we're going to deal with, for example, a very small piece of memory. We're going to say maybe this is just a 1 megabyte of memory. Nowadays, you're looking at thousands, you're looking at gigabytes, terabytes of hard drive, gigabytes of memory. This is 1 megabyte. Okay. And what this means is this piece of memory, if we want to say that each of these little slots that can be a 1 or a 0, each of these slots represent 1 bit of memory. Let's see if I can do this very good. 3, 4. Oh, it's going to be tight. 1 more. Okay, so we have 1 bit of memory here in one of these single boxes. And that can either be, for example, we could have a 0 here, a 1 here, maybe a 0, 0, 0. Maybe let's stick a 1 there. Let's just stick a bunch of zeros in here. Is that 8, by the way? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So, for example, this is kind of meaningless. The computer would look in this tiny box and say, okay, it's a 0. Well, that means nothing's there. It's empty. It's no electricity is powered to it. And that's how the computer works. RAM works because it's electronic. And either this little box or this little flip-flop type thing, whatever you want to call it, it either has power or it doesn't have power. If it doesn't have power, it's 0. If it has power, it's 1. Well, that doesn't work for us. We can't talk to a computer. We can't get it to understand things just with a value of a 1 and 0. So what we do is we string 8 of these guys together. And this is what we call a byte. B-Y-T-E. And this is 8 bits. Right? Now all of a sudden, we can get the computer to maybe say, okay, if we give you this sequence of numbers, it means this. If we give you a different sequence of numbers, it means that, right? So we can get it to understand a little bit. However, we still can't ourselves, go, okay, computer, 01000001. We don't know what we're talking about, right? I don't. So what we need to do is have kind of a conversion table. And this is called Ascii. This is what a conversion table we use that tells us, that simply says, okay, well, this is the uppercase A. This is how we understand it. And this is how the computer understands an uppercase A. So this is correct. This is actually an uppercase A in what's called binary, or one byte of binary. And this gives us an uppercase A. So now we have a way of telling the computer, okay, this means A, right? Well, if I want to say space or something, maybe we'll just pretend for a minute a space is all zeros. It's not in real life. I believe it's actually 13, which would be, it'd be probably a 1 there, a 1 there. Actually, I needed to go this way. I don't know, but let's pretend that this is a space, and then maybe this is, another letter, and so on and so forth. Well, you can see our memory's kind of filling up pretty fast. I mean, we have 1 meg of memory means we have 1,210. Oh, whoops, I did that wrong. It's 1,024 bytes. Is it bytes? Yes, bytes. So 1,024 of these rows makes up 1 byte of memory. So if I'm writing a letter, I could fill up that 1,024 bytes with just 1,024 characters, and then I'm out of memory. So this is how we communicate to our computer. We have this conversion table that's called Ascii, A-S-C-I-I. And this is so we can see what we want it to do, and we want to tell the computer. So why is, let's see. So next we want to talk a little bit, I'm going to turn off this screen. We're going to go in here, and we're going to talk about our numbering system. So we have a numbering system, and it's called base 10. Base 10, right? This simply means that we have numbers 1, 2, well, let's do 0 first. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 9 digits here, or 10 digits here, right? So when we're counting, we say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we need to have, since we can only count to 10, we need to have another row here. So now we say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you probably learned in school that this is called, these are columns. We have the ones column, right? The 1, the 10 column, the T-E-N. We have the 100 and the 1,000. And so on and so forth. So we have all these columns, and what we do is, to get the numbers we have nowadays, is we would count 1, 2, 3, 4, 5, 6, 7, 8, 9, but now we have to overflow into the next one. So we put the 1 here, and then we recount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, 0, 1, 2, 3, 4, 7, 8, 9, right? And then we put our thing over here again. Now we have a 2. We go down there and we have a 3, and then a 4, and then a 5, and then a 6. So here we have 10, 11, 12, 13, 14. Binary is the same way. However, the highest it can count is 1. It goes 0, 1. And then it has to go to the next column and say 1. And then it has to say, well, it has to go 0 again and 1 and 0 and 1 and 0 and 1 and so on and so forth. So in binary, since we can only count by 2s, this is the 1s column. I'm going to use numbers here instead of writing because I don't have much space. Then we have the 2s column, the 4s column, the 8s column, the 16 column, so on and so forth. So if we, let's go ahead and get rid of that layer real quick and put in a new one. So in binary, now remember that number we had that was 0, 1, 0, 0, 0, 0, 0, 1. And I said this is the ASCII value of A. Uppercase A too, not lowercase. This is uppercase A. So if we went and looked at this as a number now, if we convert it to, say, our base 10, we would say we have our 1s column, our 2s column, our 4s column, our 8s column, our 16s column, and our 32 column, and our 64 column, and finally, our 128 column, right? That should cover this number. Let's just verify this. So we have we have a 0, 1, a 0, 0, 0, 0, 0, and a 1. So if we add this up, we get 64, right? Because there's 1 in the 64, so there's one set of 64, and there's a 1 here. So altogether, this equals 65, which is the value of an ASCII for a uppercase letter A, 65. So hopefully that kind of helps you understand a little bit about how the computer talks. And the reason we're talking about this is because when we're programming, we need to tell the computer to reserve chunks of memory. We're going to refer to these chunks of memory. For example, this is 1 byte. Remember, 8 bits is 1 byte. And this right here alone is 1 bit. So we need to, in programming, a lot of times we need to say, okay, computer, we need to stick a value into memory that we can access. Now, computer memory actually has locations that look something, it's called something like this. So we're just going to make something up here like 6B 093A, right? Now, if I wanted to tell the computer to access this piece of memory, I could say, hey, computer, could you please tell me the value that is in 6B093A? Now, that gets hard for me to remember that what this this is the value A, right? So I could, be writing this big old program, and it'd be really easy for me to forget what was that name of the chunk of memory I needed. And so we can create what's called variables in programming. So let's go ahead and get us another layer. And we're going to call variables, we're going to refer to variables as a box, okay? So this box is a chunk of memory. And that chunk of memory, we need to tell it what we're going to store in it. Now in programming, we have various what are called data types. Data types. Right? So we have various data types that hold different types of value, because this box, once we create this box, it can only hold a data type that we tell it to. So if we, for example, say, okay, I have an integer, integer, and I want to create a location in memory of type integer. So that then says, okay, this box is now of type integer. And int is what most programming languages will use int to represent integer. Now an integer, if you remember your math, is a positive, well, it's a positive or negative whole number. So negative, positive, whole number. Now this number can't be monstrously huge, but it's generally big enough for whatever we need. We can just use an integer. You can use advanced data types and stuff to get other types of, larger numbers. But now if I say, okay, so here's type integer, so this box can only hold integers, right? But I don't want to have to call it the x or the 0x3a692b. I don't want to have to call it that. So remember how I told you we have the Ascii chart, Ascii? Well, we have the ability in programming to make it friendly, because like we said, wasn't it, it was 0, 1, 0, 0, 0, 0, 1 is A. I don't want to always have to say that every time I want an A, so we use Ascii, which says, okay, the uppercase A for us is this. The computer knows it as this, because we can't tell the computer what this is because it only understands ones and zeros. It doesn't understand letters. So we have to have a representation here of what we're wanting. And we can do the same thing here. We can say, okay, computer, you might know this as this, but I'm going to call this num1. And my program will always call this num1. Now I can put a value. I could say, okay, here's the number 5. I can put that value inside the box. Later on, I can get out of the box and I could tell the computer what number was in that box, and it would say 5, right? I could also say, okay, well, I got out of 5 at one point. I'm going to stick a new number in there. I'm going to stick 7 in there. Whoop. If I tell the computer what was num1, after, it will come out and it'll say, oh, that's 7. So we can put a value into that box and we can pull a value out of that box. We can replace the value in that box, but we can't have multiple values in that box. We can't say, okay, num1 is going to be 5 and 7. It can't do that because this box can only hold one type. Hence, it's num1. It's the first number, right? In our explanation here. So we have the data type of integer, and that's your whole number. We also have a data type that's called a double. D-O-U-B-L-E. Whoops, that's a weird B. And this is your decimal type of number. Okay, so this would be like decimal or floating point, D-E-C-I-M-A-L. Is that right? Decimal. So for example, 3.14. So I cannot put 3.14 inside this box because this box only holds whole numbers, positive or negative. I can put in a -5 and I get out a -5, but I can't put in a decimal because this is a type, a different data type. I can't put a double into an integer, right? Then we also have one called a char, C-H-A-R, right? So a char is a single letter. So I can actually put this A in there. Now when I put this A in there, and when I put this 5 in there, and when I put the 7 in there, it's not actually putting these numbers in there. It's actually putting in the binary equivalent in there. But it's smart enough to output and tell us what our view of that binary number is. So when I say a single letter, I can't put in the word dog because that's not a single letter. There's a different type that we can use to do that, and the computer kind of automatically does that too. So here we could say put in A. Now when we put in that A, whoops, it ain't going to go in that box. It can't go in that box because this is type int. We have to have another box called type char, and in which we cannot put anything other than a type char, and that is a single letter. Okay. The next type we have is called a bool, or a boolean, B-O-O-L-E-A-N, E-A-N. And a boolean can hold a value true or false, or as the computer knows it, is 1 or a 0. So we can either say, is this value set? Yes. Is this value not set? Or if we evaluate something using Boolean logic, which we'll go into later, we can get values saying, okay, so if this is true and this is true, then the whole thing's true. If this is false and this is true, the whole thing is false because it's false. One of them's false. So these are our basic data types. Now, different programming languages has advanced data types. And let's just talk a little bit really quick about data types. So let's go ahead. We're going to get rid of this layer and pull up a new one. So a type integer, a single integer variable, or a bucket, or a box that is reserved as an integer. Remember how we were saying down here we had our memory like this, and we said it's I'm not going to do this very good this time. It was 8 blocks across, right? 1, 2, 3, 4, 5, 6, 7, and 8. Oh, that's terrible. So an integer, when you declare an integer or initialize an integer, you're saying, I want to reserve 2 bytes of memory. So if you remember, 2 bytes was 8 bits in 1 byte. So this is actually 16 bits. So what I'm saying as an integer, I want to reserve this much memory. Now, if you remember, we were looking at this, and this is 1, 2, 4, 8, 16, 32. I don't think I have 8 here. 32, 64, and then 128. Right? Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So this means that, like, if I wanted the number 128 in here, that just seems weird to me, but 8, 60, 36, yeah. If I wanted the number 128 in here, I would have 1s in all these boxes, right? If I wanted 65, which we did with the letter A, I would have a 1 in that box, a 1 in that box, and all these others would be 0s. So this kind of gives you an idea of how our numbers are. So this box, because these bytes are kind of streamed together, that doesn't mean that this one is value of 1 again. It's actually whatever double this is, which is 256, and then 512, and then 1024, and then 248, and then 409, 4096, so on and so forth. And that's how it can store those numbers, right? So that's an int. We use 2 bytes of memory for an int. Next we have a double, a B, a D-O-U-B-L-E. And a double takes up 8 bytes. 8 B-Y-T-E-S. I missed my T. So a double actually is going to take up, well, double the int. I don't know if that was intentional, but the double is going to take up that much. And this is our floating point. This is our decimal numbers. This is like 3.14. This is like maybe 1, 2, 3, right? Then we have our character. Now, if you remember, our character is a single letter, right? Now, yes. A character, now we know A, B, C, D, E, F, G, all the way to Z. However, there's other language and stuff like that. In fact, let's see if I can pull up a web page real quick and just show. Let's see. Let's do. I was doing some extra little research there, but if we want to do ASCII ASCII table, we can see that it's not just the alphabet that we know. It's actually a lot more. So we have our alphabet, we have all these characters we don't know, we have our number system, we have our alphabet, uppercase and then lowercase. So 65 is the uppercase A, 97 is the lowercase a. But then we have what's called the extended ASCII codes. So this goes to the 127, right? 0 through 127, which is 128 bytes or bits or value, whatever, in binary. That whole byte is that first one. But then you'll see that we also have the extended ASCII codes, which includes other languages, special characters and such. And that takes up the next row pretty much up to, you know, the 255 and so on and so forth. So that's why when we do our char here, where did I put my pin? A char takes up 2 bytes, just like an integer. C-H-A-R. So this is just single letter, whoops, L-E-T-T-E. It's a single letter like A. And it takes up 2 bytes. Right, so here we have integer takes up 2 bytes. This one takes up 4 bytes. And a char takes up 2 bytes. All right, and then our final one that we talked about was the Boolean, right? B-O-O-L-E-A-N, which is sometimes in programs you actually just say bool. It's a bool, right? And the Boolean is the either true or false. And if you can think, let's try a little quiz here. How many bytes or bits or whatever do you think this takes up? If you said it takes up 1 bit, you were correct. This only takes up 1 bit because it's either on or off. It's true or false. It's 1 or 0. That's it, right? So these are our basic types. And like I said, different programming languages, you might have in int, you might have things called a short that maybe only takes up 1, or a long, which is a huge number, you know, that takes up more. You might in this one have floats, F-L-O-A-T, and other things I can't think of. Char's pretty much char, and Boolean's pretty much Boolean. But you might have extensions or other type of things that represent shorts and longs and so on and so forth. Now, there are some other special ones that aren't necessarily a data type, because as you can think, boy, if I have to type and say, okay, this, I'm going to have a box here, and this will be called the box A. And then this one will be our box B. And its value it has is A. And this one has B. So if I have a program, I have to say, what's in box A? If I'm spelling, let's just say, let's do this one's C, this one's D. So I want to spell the word bad, right? Or cab or something like that. Well, I would have to have a program. I say, hey, program, output to the user what's in box A, or what's in box B, right? Then I have to say, hey, computer, what's in box A? And then computer, hey, what's in box D, right? that could be kind of complex and a pain in the bum. So because of that, they also have, generally it's called string, string. And string is a special type. It's actually called basically an array, or a, and we actually have another type of an array. So an array, let's close that one, bring this one up. We're going to use string real quick, string. So string is saying that I have a lot of characters. I have a whole bunch of chars to put together, right? And so if I say, okay, so string, which is an array, I have an array of characters. And so this string, and usually we denote it with a quote, we say maybe a, and then a space, and a bad space boy. I don't know why, because we did. So what this string actually is holding is a whole bunch of chars in a row. One that's a space, one that's a B, one that's an A, one that's a D, one that's another space, one that's a B, one that's an O, one that's a Y, right? So this is actually holding, it's actually an array of chars. And that's what a string is. And this makes it so we can actually say, in quotes, this is the value. This is the sentence I want you to have, or the phrase, or whatever. And the computer will automatically say, okay, well, each of these are actually a thing. And then the computer simply says that it needs to access these. So what the computer does with the array is, when we create this, it says, okay, these are all type char. And even if we stuck in a bad boy with like an exclamation point or a number, it's looking at that as a type char. It's not looking at it as a number that it can multiply, subtract, or anything like that. It's a char. It's a letter, right? So what this computer is going to do then is, when we create this, it's going to create the array, and it's going to say, okay, inside this array called that's being called string, if we call this, let's just say, for example, string, string, and say, we'll call it my words, maybe, my word, my sentence, I don't know. And that sentence is going to be whatever we have up there, right? So what the computer does then is it goes and it says, okay, here is what he's setting it to, and I need to be able to access these. And so it simply does a numbering system. It says, this is an element, this one's going to be 0, this is going to be 1, this is going to be 2, 3, 4, 5, 6, 7, 8, right? And each of these are actually a char. So each of these in our memory thing here is taking up, oh boy, here we go again. We'll pretend that's 8. Right, so each of these is taking up, that's the A, that's the space, that's the B, that's the A, that's the D, that's the next space, and so on and so forth. So it's reserving in memory and putting these in memory, but it's actually remembering to chain them together, saying, okay, for me, this is my word, but it's in an element. So we would say something maybe like, my word, and we want element number 2. And if we told the computer to tell me what's in element number 2, it would come in the memory and it would say, oh, this whole thing here is the my word, and he wants element number 2. So it would say, okay, here's 0, here's 1, here's 2. And it would say, oh, he wants the letter B. So that's kind of confusing, and hopefully as we go on, we'll understand this a little better. We'll kind of round out and finite all this different stuff as we continue on with the different programming. So now we have a way that we can give the computer stuff that we understand, and the computer has a way of taking that stuff and looking at its ASCII table and saying, okay, I understand this in my way. So we have a communication, kind of a Rosetta Stone for the computer is what our ASCII table is. And now we can actually start talking to the computer, and the computer can give us back replies that we understand instead of just saying, put it on the screen a whole bunch of ones and zeros. Well, all we're going to see is a bunch of ones and zeros. That'll mean nothing, and move on. So the other types we have the string, which is an array of characters, but we also have arrays that we can set up ourselves. So we could also have an array. I forgot about this almost, RRAY. So we could have an array that is integers, right? So we could say this is an array of integers, or we just say that it's an array and we're going to put in element number 0, we're going to put maybe 25, right? Remember how we couldn't stick the, where is it? I think it's like, nope, nope, nope. No, I think I might have actually deleted that one. Remember how we couldn't stick a 5 and a 7 in there at the same time? Well, that's where the array comes in. Now we can say, okay, here's an array of numbers, and the first one's 25, the next one is maybe 7, the next one's 5, and we can access these numbers by the array element. So we can say, computer, tell me what's in the my array of numbers, or my numbers, in array element number 1, and it would output 7. We could say, okay, now what's in array element number 2, and it would output our 5. So we can store greater amounts of things in there. Okay. All right. So there is one other kind of type, and it's called an object. Not all programming languages use these. However, quite a few do. They're called OOP, or object-oriented programming languages. Java's one, C++, C#, are some. PHP is also one, but then there's others that aren't, like the BASIC, some of the earliest BASIC. I don't believe that's an object-oriented. Perl, I don't think is, and so on and so forth. And we're going to talk about these different types of things and stuff. But what I really wanted to get out this lesson is kind of how we get information to the computer, how we tell it what we want, and how we get back what we want, and it actually understands us. So hopefully you guys understood this, and hopefully you enjoyed it. If you did, be sure to leave a thumbs up down below. Aside from that, comment, like, subscribe. Check out my other channels. They're not all programming and stuff like that. I have a gaming channel, the Tazman channel. This one's T4zzTeaches. And then I also have Taz Unplugged for games that I can't really control what they say. They're usually your rated M's or something like that. But check those out. And that's it. In our next lesson, I think we will probably start diving into some of the Boolean logic, and maybe even some of how the computer makes decisions. But hope you enjoyed. So anyway, until next time, I'll be seeing you later. Bye.